A cat sealed in a box becomes the most impossible creature ever imagined by science, both alive and dead at once. This is the Schrödinger paradox, a single thought experiment that shattered the boundary between what exists and what is merely possible. Erwin Schrödinger devised it in 1935 to expose the absurd implications of quantum mechanics. According to the equations, an atom can exist in a superposition, a blend of mutually exclusive states, until it is observed. If that atom's decay triggers a vial of poison, then the cat's life becomes entangled with a microscopic event. Before anyone opens the box, physics describes the cat as simultaneously living and dying, suspended in an unresolved wave of probability. Observation, not time, determines its fate. This idea didn't simply challenge how matter behaves, it questioned what it means for anything to be. Quantum mechanics implies that the physical world does not have definite properties until it is measured, that existence itself may depend on interaction. The cat is not a metaphor for uncertainty. It is the embodiment of a universe that refuses to decide until someone looks. The true shock lies in the experiment's intent. Schrödinger meant to mock the quantum logic that produced it, to reveal the absurdity of applying subatomic rules to ordinary life. But instead, the paradox revealed something deeper, that the line between quantum and classical reality may be an illusion we invented to feel safe. When the box is closed, the cat's state defies logic. When it opens, logic defies reality. And in that instant of observation, the universe seems to notice itself. To grasp how the cat becomes both alive and dead, we must first understand the strange arithmetic of quantum reality. In the quantum world, every particle, an electron, an atom, even a photon of light, is described by a wave function. This isn't a physical wave, but a mathematical one, a probability field encoding every possible state the particle could take. Position, momentum, spin, all coexist within it superimposed. Before measurement, these possibilities don't compete, they coexist. An electron isn't here or there. It is both, described by a single equation that includes every location it could occupy. Only when we measure it does the wave function collapse, forcing nature to pick one outcome. The measurement doesn't merely reveal reality, it creates it. In Schrödinger's setup, a single quantum event, the decay of a radioactive atom, determines the macroscopic fate of the cat. If the atom decays, a detector triggers poison. If not, the cat lives. But because the atom exists in a superposition of decayed and undecayed states, the entire system, detector, poison, cat, also enters a superposition. The boundaries of quantum indeterminacy expand to engulf the familiar world. Mathematically, this means the cat's wave function includes two simultaneous branches, one alive, one dead. Each is internally consistent, yet both exist within the same equation until observation splits them. The universe at that moment carries contradictory truths with equal weight. Superposition isn't just uncertainty, it's coexistence. The cat isn't waiting for you to look. It is both outcomes woven together by the logic of quantum mathematics. And that logic quietly suggests something vertiginous, that what we call reality is not a state of things, but a state of knowledge. When we look, the wave collapses. When we don't, the universe remains undecided, yet entirely real. The paradox expands when superposition is no longer confined to a single particle, but shared between two. When systems interact and then separate, they can remain connected by a single quantum state, a phenomenon known as entanglement. It is not a force between them, but a structure of information, one wave function describing both. Measure one particle, and the other's properties become instantly defined, no matter how far apart they are. Einstein called this spooky action at a distance, suspecting that hidden variables must secretly determine the outcomes in advance. But in 1964, John Bell proved that no theory based on local hidden variables could reproduce quantum predictions. Decades of experiments confirmed violations of Bell's inequalities. The universe is non-local. Correlations appear that no classical mechanism can explain. The implication is devastatingly clear. Quantum reality does not respect the separateness of things. When Schrödinger's cat becomes entangled with the atom, its fate is no longer independent. The atom's quantum uncertainty infects the macroscopic world. Decay and survival are bound together. Observation collapses both simultaneously because, in a precise sense, they are one system. Reality itself becomes a network of dependencies where the state of any part is inseparable from the whole. Entanglement reveals that information is more fundamental than matter. What determines the cat's life or death is not a signal traveling between objects, but the relational structure that already unites them. The boundary between observer and observed, between here and there, dissolves. The world doesn't exist as isolated facts stitched together by space. It exists as correlations that are space, and every observation, every thought, is just one strand of this invisible web deciding what the universe becomes. At the core of the Schrödinger paradox stands a question that modern physics still cannot answer. When does possibility become fact? Quantum mechanics describes every system through a wave function that evolves deterministically according to the Schrödinger equation. But the moment an observation occurs, this smooth evolution snaps. A single outcome emerges from a cloud of potential ones, and the rest vanish as if they never existed. This discontinuity is not predicted by the equation. It is added by interpretation. The theory works perfectly in practice, but it refuses to say what observation truly means. In the laboratory, a photon may travel through two paths at once until it hits a detector, at which point it appears to have chosen one. But what counts as the detector? A piece of glass? A photodiode? The eye of a physicist? The moment of collapse cannot be defined by physical law. It depends on what we call a measurement. That ambiguity fractures our confidence that the universe is objective. The Copenhagen interpretation, the view dominant for most of the 20th century, accepts this ambiguity as fundamental. It claims that physics doesn't describe reality itself, only what can be known about it. Before observation, the system has no definite state. After observation, it does. The act of measurement is not a disturbance, but a creative event. It brings the outcome into existence. Schrödinger's cat, therefore, is not merely unknown before the box opens. It is not meaningfully alive or dead at all. The question has no answer until asked. Other physicists rejected that notion. They argued that collapse must be a real process, a physical transition governed by hidden dynamics or environmental interaction. This gave rise to decoherence theory, in which the fragile quantum state entangles with countless particles in its surroundings until interference patterns are lost. Superposition doesn't disappear. It merely becomes inaccessible. The system appears classical because we can no longer observe the quantum correlations that still exist in principle. Yet decoherence, while explaining how the illusion of collapse arises, does not tell us why we see one definite reality instead of many. The measurement problem, therefore, sits like a mirror inside physics. It reflects our own participation in the experiment. If observation selects reality, then the universe is not an independent object. It is a conversation between matter and awareness. Perhaps the cat's fate was never hidden in the box at all. Perhaps the box was always inside the observer. To understand how the classical world appears solid while the quantum world remains fluid, we must examine one of the most subtle concepts in modern physics: decoherence. It is often misunderstood as the process that collapses the wave function, but in truth, it explains something more intricate: how the appearance of collapse emerges without requiring nature to make an actual decision. Every quantum system is entangled with its surroundings. Even the faintest vibration, photon, or air molecule carries away fragments of information about its state. Over time, these countless interactions disperse quantum coherence, the delicate interference patterns that allow superposition to exist. The system does not lose its wave function. It becomes correlated with the environment's vast number of degrees of freedom. Mathematically, the global wave function remains intact, but from the perspective of any observer, interference becomes effectively impossible to detect. This is decoherence, the bleeding of quantum possibility into the environment until only classical certainty remains visible. It does not destroy superposition. It hides it beneath an ocean of microscopic entanglements. Every object around you, a stone, a tree, your own body, is in a constant state of decoherence, interacting with trillions of particles every instant. The world seems definite because it is overwhelmingly entangled. The illusion of stability arises not from the absence of quantum behavior, but from its overabundance. In this view, the cat in Schrödinger's box never chooses. Instead, it becomes entangled with the air, the box, the table, the photons bouncing off its fur, until every possible version of the cat leaves its trace somewhere in the universe. The observer doesn't collapse the wave function. They merely join it, becoming part of the entangled whole. What we experience as a single coherent outcome is just the slice of the universal wave function in which we exist. Decoherence resolves part of the paradox, but not its essence. It explains how classicality emerges, but not why our awareness aligns with only one version of reality. The mathematics allows all branches to coexist, yet consciousness experiences only one. That missing connection between objective evolution and subjective experience remains physics' most silent mystery. The cat's paradox thus persists in a new form. The world never truly collapses. We do. And the act of perception may be nothing more than the universe narrowing itself to a single point of view. If decoherence hides superposition without destroying it, then perhaps the wave function never collapses at all. This is the radical proposal made in 1957 by Hugh Everett III, an idea so audacious that it redefined what it means for anything to happen. According to Everett's many worlds interpretation, quantum mechanics is complete as it stands. The wave function's evolution is perfectly deterministic. Every possible outcome of a quantum event becomes real, but each unfolds in a separate, non-communicating branch of the universe. In the Schrödinger paradox, this means the cat does not face an ambiguous fate. The atom decays and doesn't decay. The poison releases and doesn't release. The cat dies and lives. Both outcomes occur, each in a distinct world born from the same quantum event. When you open the box, you also split. One version of you finds a living cat. Another sees it lifeless. From within each branch, it feels as though a single outcome has been chosen. But from the outside, from the perspective of the universal wave function, nothing has collapsed. Reality has merely multiplied. This interpretation transforms the meaning of probability. The chance of finding the cat alive is not randomness, but a measure of how much of the universal wave function contains that result. Every event, from a photon's path to a human decision, becomes a branching point where the cosmos divides into parallel versions of itself. Infinity is not distant. It unfolds at every quantum interaction. Critics find this extravagant, an endless proliferation of worlds to explain a single observation. But Everett's logic is brutally consistent. Since collapse cannot be derived from quantum law, denying it is the simplest option. The cost of that simplicity is metaphysical vertigo. If all outcomes exist, then the universe is not a single narrative but an infinite library of simultaneous stories, each as real as the one you read now. The many worlds interpretation turns the observer's role inside out. Observation no longer selects reality. It separates it. Every act of perception fractures the cosmos into versions of you, each certain they are the only one. The paradox of the cat thus becomes a mirror for existence itself. The price of certainty is multiplicity. You do not collapse the universe when you look. You divide it, and remain alive in every version that continues to look back. If every quantum event generates multiple branches of reality, then what becomes of choice? Under the many worlds interpretation, every decision you make, or could make, already exists in some version of the universe. Each possibility that could unfold does unfold, with another you living out its consequences. Free will, once the deepest proof of individuality, begins to dissolve into a pattern of inevitability distributed across infinite worlds. From within one branch, you experience a single path as if chosen. But the mathematics suggests something colder and stranger, that you never choose among possibilities. You simply find yourself inside one branch, where a specific outcome has already been realized. The act of choosing feels authentic because consciousness cannot perceive its own splitting. You experience continuity, unaware that the wave function of the self has divided into countless versions that will never meet again. This perspective reframes probability as experience. When you flip a coin, quantum indeterminacy guarantees both heads and tails occur. The odds you assign, 50-50, are not physical chances but measures of which world you will find yourself in. What we call randomness is simply the self navigating its own branching structure. The uncertainty is not in nature, it is in the observer's future identity. Yet, paradoxically, this interpretation restores a deeper kind of order. The universe no longer makes arbitrary choices. It evolves according to a single, universal equation, one that contains every possible history simultaneously. What we perceive as spontaneity or luck is merely the limited viewpoint of beings confined to one branch of a boundless wave. Every possibility is realized, but no observer can ever see more than one realization. If all outcomes occur, the concept of fate becomes redundant. Everything that can happen does happen, but you are confined to the thin slice of reality that defines your present. You are both inevitable and unique, a single thread in an infinite weave that includes every other version of you. The paradox turns inward. If all choices exist, what is the meaning of choosing? Perhaps the illusion of free will is not a flaw, but a necessity, the mechanism by which one version of consciousness experiences itself as real. The universe does not ask which path you will take. It already contains them all, and still waits for you to walk each one. The Schrödinger paradox becomes most unsettling when its logic turns inward. If observation collapses, or divides, the universe, then the observer cannot remain untouched. The mind that perceives the cat is itself part of the wave function. Consciousness, in this view, is not standing outside reality, but woven into the same quantum fabric it tries to measure. The act of awareness is not separate from the system observed. It is an event within it. Neuroscience portrays the brain as a network of electrochemical signals, measurable and classical. But beneath that apparent solidity lies a sea of quantum activity. Electrons tunneling between neurons, photons triggering molecules in the retina, waves of probability guiding ion flows across synapses. Each of these events obeys the same indeterminate laws that govern the atom in Schrödinger's box. If the brain is composed of quantum systems, then consciousness may, at least in part, inherit their uncertainty. Awareness itself could be a macroscopic form of superposition, an evolving field of possibilities rather than a single state. Some physicists and philosophers have suggested that what we call the present moment is precisely this quantum ambiguity, stabilized by decoherence into the illusion of continuity. When you decide, when you perceive, countless microscopic events entangle to produce one macroscopic result, a unified sense of self. Yet in the deeper mathematics, that unity is provisional, a structure maintained by observation itself. You are not an observer watching reality unfold. You are the process by which reality comes into focus. This transforms the paradox completely. The cat's uncertainty is not confined to the box. It extends into the observer's mind. You think you open the lid to reveal the cat's fate, but the act of looking also defines you. Each perception carves a boundary between what is known and what could have been known, collapsing infinite cognitive possibilities into a single conscious experience. If consciousness participates in the same quantum rules it tries to interpret, then the self becomes both the witness and the wave. Your awareness doesn't stand apart from the universe. It's the universe reflecting upon itself through the narrow lens of one moment in one branch. The paradox of the cat is not that it is both dead and alive. It's that you are both observer and observed, and can never tell which came first. At this stage, the paradox of Schrödinger's cat no longer concerns a cat at all. It concerns the fabric of existence. If observation, entanglement, and consciousness all operate as exchanges of information, then perhaps reality itself is information. The equations of quantum mechanics do not describe solid objects moving through space. They describe the evolution of probabilities, mathematical instructions governing how information transforms when systems interact. Matter, energy, even space-time may be the emergent surface of a deeper informational substrate. In quantum theory, the wave function encodes every potential state a system can occupy. Measurement is the act of extracting one piece of that information, reducing infinite possibilities to a single bit: alive or dead, spin up or spin down, 0 or 1. The structure of quantum mechanics therefore mirrors the logic of computation. The universe behaves less like a machine made of particles and more like a vast quantum computer performing continuous calculations. Every interaction updates the cosmic code. Every observation writes a new line into the program of reality. This view aligns with what physicist John Archibald Wheeler called it from bit, the idea that every physical it, every particle, field, and constant of nature, arises from binary informational choices, the yes-no decisions made whenever an observation occurs. Reality, then, is not built from matter, but from meaning, defined by the answers the universe gives to its own questions. The Schrödinger paradox exposes the tension within that code. Before observation, the wave function represents an undecided algorithm, a computation that is not yet resolved. The cat's fate is not unknown. It is uncomputed. When you open the box, you do not discover what was already true. You execute the operation that makes it true. In this informational universe, existence itself becomes relational. The cat, the observer, and the environment are not separate entities exchanging signals. They are nodes in a self-referential network where each defines the others by the information they share. What we perceive as material objects are stabilized packets of data. patterns resilient enough to persist across interactions. The solidity of the world is the persistence of memory. And so the paradox evolves. The cat's dual state is not a flaw in nature, but a feature of its code. Uncertainty is not ignorance. It is the fundamental syntax of being. Reality is not the story the universe tells. It is the language in which the universe computes itself. By now, the paradox has unfolded across every scale, from the atom to the mind, from matter to information. Yet the deeper truth that Schrödinger's cat reveals is not chaos, but coherence. What appears to be contradiction, alive and dead, wave and particle, observer and observed, may be the universe's way of maintaining balance between possibility and actuality. The cat's duality is not a mistake in logic. It is the logic of existence operating at full resolution. Quantum mechanics shows that nature is fundamentally relational. No property exists in isolation. It becomes real only through interaction. This principle, once confined to particles, expands to everything. The classical world is not separate from the quantum one. It is its collective resonance, the large-scale echo of countless entanglements resolving into patterns we can perceive. What we call reality is the macroscopic coherence of quantum probabilities aligning just long enough to appear stable. The paradox dissolves when we see that superposition and collapse are not opposites, but phases of the same process. Superposition is potential, a spectrum of all possible states. Collapse is the expression of that potential through context. The universe does not oscillate between ambiguity and certainty. It requires both. Possibility gives existence its depth. Observation gives it its form. Without either, the world would be empty or undefined, a void that never becomes anything. Decoherence, entanglement, and observation form a single cycle of transformation. Information spreads, correlations form, awareness selects, and coherence re-emerges at a higher level. Each act of measurement creates new order out of uncertainty, just as each thought creates meaning from chaos. The paradox only seems to break logic because logic itself evolved within the fragment of the universe that has already chosen. To see both sides of the cat, both being and becoming, is to glimpse logic before it splits. Perhaps the Schrödinger paradox endures because it reflects the structure of the universe itself, an infinite equation balancing between what is possible and what is perceived. Every contradiction we encounter may be the surface trace of a deeper unity we are not yet able to observe directly, a coherence so complete it must appear divided. The cat's box was never meant to be opened. It was meant to show us that reality is already open, a single wave forever observing itself. In the end, Schrödinger's cat is not a riddle to be solved, but a mirror held up to existence. The experiment began as satire, meant to expose the absurdity of quantum logic when applied to ordinary life. Yet, almost a century later, it has revealed the most profound insight in modern science. That observation is not a passive act within the universe. It is the act by which the universe becomes real. When the box opens, the wave function doesn't simply collapse. Reality converges on a single version of itself. But the observer is also part of that convergence. Every look, every thought, every awareness is an interaction that defines what is. The cat's paradox endures because it exposes the circularity at the core of existence. The observer and the observed are two sides of one continuous process, each giving the other meaning. From quantum superpositions to human consciousness, the same pattern repeats, information transforming into experience, possibility crystallizing into fact. The world does not exist independently of observation, yet observation is impossible without the world. Reality and awareness arise together, locked in perfect symmetry, like two mirrors facing each other across infinity. The illusion of separation is the price of experience. The feeling of unity is its reward. Perhaps the final resolution is not that the cat is alive or dead, nor that both states exist in parallel, but that the distinction itself is part of the experiment. We do not merely open the box. We are the box, the wave, the observer, and the observed. Every conscious moment is a miniature Schrödinger experiment, collapsing endless quantum potentials into the single unfolding reality we call now. The paradox never truly ends. It only deepens into understanding. The universe does not wait to be observed. It is observation, an infinite field of possibilities forever watching itself come into being. Write in the comments, I still exist in the version that observes.